Hello everybody and welcome to Surface Geometry 4. So in this question we're going to be doing another development of a transition piece before we go back to our standard roof, if we can call it that. Now this transition piece here is a circular on the bottom and it's circular on top. It's offset, okay, otherwise it would be very easy. And what we're going to do is break it down into a number of surfaces. Now, just before we get into that, I just want to talk about triangles for a minute, and I've talked about this before. Here I'm looking at a flat 2D triangle. Now, in the elevation, that's line 1, line 2, and line 3. But something I want you to bear in mind as we go through this question is that when we're looking at the plan view of a line, that can be a triangle, okay? And you can be looking at a few different things here. You can be looking at a point view of line 1. You can be looking at the sloping edge of 3, and you can be looking at the true length of 2. Okay, so just bear that in mind. Now, to go back to this, I broke it down into 12 equal sections. I divided up both circles with our standard 60-30 method, and then I joined in these generators. Okay, so there's 12 of them there. Starts at 1 to A, 2 to B, etc. But that won't be enough. Now, if you remember back to our last tutorial, we broke things down into triangles. And we're going to do the same in this question as well. So I'm going to have these diagonal lines dividing up these little surfaces. And I'd like you to go ahead and put them in now as well, please. Now I have it divided into 24, okay? And we know from the last tutorial, if you need to break down, we'll say if you were asked there for the true shape of that surface there, you'd get the true length of the line 6 to E, okay? You'd get the true length of 6 to F, and then you just get this step off this distance here, okay? So when you have the three distances, you can just draw down one line and then swing the other two distances, and that will get you your true shape. So just to go back again to this triangle, like if I take that line there from 6 to F, okay, what am I looking at there? I'm looking at a triangle. I'm looking at the vertical, a vertical line there, the point view. The base of that triangle, that's it. That's the true length of the base from 6 to F. But the sloping line I need to draw. Now you could go off over here and draw them out, but I'm just going to swing them around, rabat them, and bring them up. For example, 6 to F, if I marked off that distance there, I could draw a line straight up here, and then that would get me the true length there. So for drawing right angle triangles, usually you only need to know maybe the height and the base, or the base and the angle it's sloping up at, okay? But we're going to solve this by rabatting around the line, so we're looking at them at 90 degrees. So you can start anywhere you want. I think I might as well start here at A to 1, or start at 7 to G, because they're true length lines in elevation already. Now just to say to you, this is going to be a slow enough question because you'll be doing a lot of compass work, okay? But we'll kick off anyways. So you can start the development anywhere on your page. So if I take that there, that distance, and I let that be 1 and that be A, and I'm going to start off there. Now, what I want to get first of all is I want to get this little triangle here, okay? So that's the line 1 to A. So the distance from 1 to 12, I can see that straight away there. So I can get my compass and mark that off. Swing a little arc here. 12 will be somewhere on that line. But what I need to find out is, I need to find out the true length of that sloping from 8 to 12, okay? So what I could do there is, I could put it down here on this, and I could rabat around 12, swing it around, okay? Bring it up to my elevation. This will get me the true length of that line from 8 to 12, okay? So that's 8 to 12, the true length. Now I'll take that distance there. Actually, I'll have to step it off with my compass. Get that distance there. Bring it over here. Put it on A. Where the two arcs that meet there will give me 12. So that's point 12 found. Now I have that little piece done, and if you want, you could even shade it in as you're going along. Now I need to find the true shape of this here. So I have 12, and actually I'll just draw in that green line in my development. I want to find L now, is the next one I want to find. So I know that the distance from A to L is this, so I can step it off here. And I can swing it this arc. L will be somewhere on that arc. Okay. Now, what I need to find out though is I need to find out the true length of this sloping line. I'm just looking at the true length of the baseline of that triangle there. So again, get your compass. Swing it around. Bring it up. Okay, so it'll be there. And then I'm just going to join it down. I'm going to put it in a dashed line so it won't mix it up with the other generators. That is the true length now of that sloping line, that generator from 12 to L. So get your compass. Mark it off. If I put it on 12 here now, swing that arc, that will get me L. Okay, and we just keep going onwards. Next, so now I've got that as well. Next one I want to get there is I'm going to look for, you can look for either one of them really. I'm going to look for the point L, or K, sorry. So again, I know K is going to be this distance here. Okay, step it off, swing an arc from L. Somewhere on this arc will be K. And now what we need is the true length of that sloping line. I'll just do a horizontal line there. Stretch out my compass. I'm going to drop it down. I'll bring it up. So I'm just rebatting that around now. It's going up. It'll still have to go to this height, and then it's just going to join back down to K there. And that's the true length of that diagonal. Grab it there with your compass. Put it on 12, swing, and that gives me the point K. Next after that, so that's that little area done, I'm going to look for this distance here. So I need to find, I want to find point 11. Mark off that. 11 is going to be somewhere on this little arc here. Now what I need to find out here is the true length of this generator. So it's the same thing, we just keep repeating it over and over. bring it up to there, to the top. So if you're batting down a point from the top, it has to go back up to the top, and then you join it back down onto K there. So this is the distance I want now, from there to K. That's the true length of that sloping generator. Swing from K. That'll find me point 11 there. So I'm going to stop now talking now, and I'm just going to keep going on doing the same thing there. Now we have this true length line here, 70G, we have the true length line up there already. So we can just take that and we can mark it off there. And that will give us half of the development. Okay, so not for the faint-hearted folks. Once you have that done, just join in our 0.3 hand. Now, so if you do half of the development, I would be happy with that, okay? As you can see, you know, there's an awful lot of lines crossing, so you have to be very careful about it. It would be very easy to pick up the wrong line, okay? But just take your time, keep it steady, you know, and keep going through it one triangle at a time, you know, and that method of triangulation will let you develop a surface like that, okay? So we're going to leave this after this, folks, and go back to our more standardized roofing questions in surface geometry. But at the same time, we need to kind of have a look at this stuff, and we will come back to it again as we're going through questions. So I hope you found that useful, folks. Take care, stay safe, we'll talk to you soon.